video, we'll be calculating, or rather finding, inverse of a function. Inverse operation is Inverse operations are performed so that the output of a function turns into the input and the input turns into the output. The notation of -1 on top of f doesn't mean the power of f, so don't confuse that with 1 over f. This is completely different. The inverse of a function is written like so. Okay, so if we take an inverse of a function and feed it back to the function, that would give us the original x, right? And vice versa. So let's see what's going on. Let's function is simply y equals to 5x through the origin. What's the inverse of this function? If we make y the subject of this formula, then x will be 1/5 of y. Okay, then what we write is that the inverse of the function of x rather than input of y will be 1/5 of x. Therefore, when we plot this graph, it will reflect as though it was reflected in this line here. This line is the line where y equals to x. Function actually looks always reflects in the y equals to x line. Okay, this symmetry is due to the fact that the inputs become outputs and the outputs become the input of the function. So that means that the domain and range swap sides. The domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse function. That is why we had to make sure the functions are one-to-one so that we could find their inverses. We said that the function y equals to x squared is many to one. Therefore, if we want to find this inverse, it's impossible because the square root of y, the square root of x is not a function. But we can do some tricks to actually make sure this does work. If we exclude all negative values of x from the domain, that is, we bound our x to be always positive or bigger than 0, then the, the range of the output will not go to negative values. That means that the f inverse will be only looking at the positive part of the graph of the square root of x. The x's will only map onto these positive values of y. Therefore, we need to make some adjustments. But for the most part, we only need to understand that what's a function and what's not a function at this stage. Asked in this example to calculate the inverse of this function. What do? Well, x is any real value, and we've been bounding x so that x will not be equal to 1. So we would never divide by 0 here. Okay, so what we need to do is replace f of x with y equals to and make y the subject of this formula. We'll multiply and divide by y. We multiply by x minus 1 and divide by y. Doing it. Another way of doing it is to multiply out the bracket here for y and make x subject to this formula. Okay, so that's one way of writing inverse of x. At this stage, we could have made x the subject of the formula by writing x minus 1 equals to 3 over y, and we could have added 1 to this fraction here, 3 over y plus 1. Then we would have written 1 as y over y, so that we would have this notation here. When you want to write an inverse, instead of using y, you write this notation, and we always use x in our inverse notation as well. So these y's here need to be replaced with x. So we would have written 3 plus x over x. So in this next example, we got a square root of x minus 2, where x is always bigger than positive 2. Why is there this restriction of x? Because we cannot have negative values under the square root. So state the range of f of x. Range means the output. The output of a function can be any positive or real values. So some number under the square root will make sure that the f of x will work. What does that mean? The question is asking us to find the function f inverse of x and state its domain and range. And the last part is asking us to sketch the graphs of the original function and the inverse function and draw the line of y equals to x. So let's start with part A, stating the range of f of x. Well, x can be equal to 2. What happens if we substitute 2 into the equation of f of x? We'll get 0. So we know our y values, lowest value of y is 0. And the x values can increase up to infinity because x can take any real value as long as it's bigger than 2. So you should know that the square root function is increasing on the top side on any values above the x-axis. So it can go up to infinity. Okay, there is no upper bound or limit here. If we draw the graph, it will look something like so. So you should write your answer exactly like so. Writing f of x can take any real value as long as it's positive or equal to 0. So in part B, we've been asked to calculate the inverse of this function. What we do is replace f of x with y, square both sides, add 2 to both sides, and we have x made the subject of the formula. Now we replace what y is with another x, and we get rid of the x on the right. We will write f inverse equals to x squared plus 2 rather than y squared plus 2. To find the range and domain of this inverse function. Well, we know that the input or the range and domain will swap sides from the original function to the inverse function. If we check what the domain was x is being bigger than 2. Therefore, it will always be bigger than 2. Inverse function, as you see here, has its domain being always positive, and its range is going to be always bigger than 2. So make sure you understand that the domain of the original function will be the range of the inverse, and the range of the original function will be the domain of our inverse. Okay, so plot the curves and answer part C. The square root function looked something like so, and the positive part of the graph for quadratic is x squared shifted up by 2 units. Right, this line y equals 2x is clear to see that they are reflections of each other. That is, the red curve below the blue line is reflected in the blue line. Next example, we've been asked we've been given x squared minus 3 is the function, and x is always positive or equal to 0 for the domain. We've been asked to find the inverse of this function. Then we'll be we'll be stating the domain of the inverse and solve that equation there. So let's replace f of x with y and make x the subject of this formula. Okay, so now we are to sketch this graph and state the domain. That is, what values can we put under this square root? Well, the square root will only work if we give it a positive value. Therefore, x plus 3 must be equal or bigger than 0. That means x has to be bigger or equal to 3. Therefore, that's the domain of the inverse function. F of x must be always bigger than f of x is always bigger than minus 3. So x must be bigger than minus 3 to satisfy the domain. The graph of the square root function looks like, or the inverse. X must be always bigger than minus 3 for it to work. So it's clear that the two graphs are reflections of each other. Next part, we'll be asked to match the left side and the right side of this. This is f of x being x squared minus 3, and we figured out the inverse of the function is square root of x plus 3. That means we have to write this equals to the original function, x squared minus 3. Okay, so let's see how to do this. First of all, we have to restrict our domain so that x plus 3 will have to be a positive value. So for this to be positive or equal to 0, that means that x has to be bigger or equal to negative 3. So that is the domain of the inverse function for part B of this question. Now, to answer part C of this question, you might be tempted to write x squared minus 3 equals to square root of x plus 3. But this is one of those equations where you cannot find an easy answer. Algebraically, that means squaring x squared minus 3, and this is not going to help us because it cannot be solved with rudimentary methods. So let's consider the graph and think carefully about it. Alright, so if we plot the graph of the original function and its inverse, what you'd know is that they will have only one intersection point. What is this point here? That is where y equals to x. Okay, because we already know that these two functions are reflections of each other in the y equals to x line. So rather than solving x squared minus 3 equals to root of x minus 3, all we have to do is replace this with x value of x itself, because y will be x. Therefore, we write x minus 3 equals to x and solve it like so. This is an easier method than going through the algebraic methods that may not work. So, what we said is that we're going to write x squared minus 3 equals to x, because that's the output of the inverse function, and bring x to one side of the equation and solve it with the quadratic formula. Our answer will turn out to be we said the answer comes out to be 1 plus root 13 over 2. Notice we didn't have to do it that way either. We chose f of x to equal for f of x to equal to x, but we could have also written f inverse of x equals to x. Having written x plus 3 under the square root equals to x, we would get exactly the same formula. Just square both sides, and you get x plus 3 equals to x, and subtract x squared from both sides, or rather take the left to the right, and you end up with the same expression. So I hope you found this helpful. I'll see you in the next video.